Okay, so we're starting with exponential and logarithmic functions, and you know, this is again, where do we see exponential functions, right? So imagine, right, somebody is, sick, right? They have the flu, you're together, and then, a few hours later, you start feeling like a little tickle in your throat, right? And then 4 hours later, what happens? All of a sudden, you're just, bedridden, you've got the flu, and so on. So what happened? Your friend had the flu with all this bacteria. You had virtually none. Um, some bacteria came onto you, and then within a matter of hours, what happened? They increased, right? So you went from not having any bacteria in you to all of a sudden having a huge amount of bacteria in you, and it's making you just feel miserable. So what does that mean? What happened? Look at how quickly the bacteria increased. That's an example of exponential growth, okay? And so what happens? So you go to the doctor gives you some antibiotics, right? You start taking the antibiotics, and then what happens once you start taking the antibiotics? All of a sudden you start feeling better. So just as quickly as the bacteria in your body multiplied, it now dies down. Okay? So that is an example of an exponential function, something that changes very, very quickly, whether increasing or decreasing. Okay? All right. So exponential functions, we say, are power functions. But now, how are we used to seeing powers? No, normally, when I see a power, right, it's like x to the power of 2 or x to the power of 1/2, right? X to the power of 4. You have the base on the bottom, and you've got the exponent as a number, right? Well, here in exponential functions, it gets reversed. What happens is the base is a constant and the exponent is a variable, right? So take a look at some examples here. I have f of x is equal to 4 to the power of x. So all of a sudden, this is the number and this is the exponent. That's the variable, right? So things have switched. Another example, 1 over 3 to the x, right? And you can see some examples here. 3 to the x, 1/2 to the x, right? Or this is another exponential function, e to the power of x minus 1, right? Have you guys seen e before in intermediate or algebra 2? Yeah, okay. So let's take a look at what all this looks like. When we have exponential functions, just like I talked about in your body, the number of bacteria can grow or it can decay. When something is growing, and it could be bacteria, it could be a population of humans, it could be a population of animals in an ecosystem. When something is growing, we say that's exponential growth, right? The graph of it looks like this, okay? It's got the same shape every single time. So let's see some characteristics here. The most important characteristic is that there is a horizontal asymptote. You guys remember tangents and secants and cosecants had asymptotes, right? A tangent that we did had a vertical asymptote. This one has a horizontal asymptote, and the default is y equals 0. Okay, so that's one of the things you're always going to be asked. That what is the horizontal asymptote for your function? Okay. Domain. The domain for all exponential functions is all real numbers. Okay, so it exists throughout your x-axis. And now the range. The range is very, very important here as well. Your range looks like this. It always looks like y is greater than or less than something. And the way it looks is this. It's y is greater than whatever the horizontal asymptote is. So in this case, if the horizontal asymptote is y equals 0, then the range is y is greater than 0 or y is less than 0, right? More details on that to come soon, okay? All right. So exponential decay. This is when something is decreasing, when you have like a population of animals and then all of a sudden, the food supply goes low and the number goes down, right? You've got the flu, you take antibiotics and all of a sudden the population of the bacteria decays. That's exponential decay, something goes down. Again, there is a horizontal asymptote at y equals 0. The domain is again all real numbers. And then the range looks exactly the same. Y is greater than the asymptote or less than. Okay, questions? Okay, so this is how the graphs of growth and decay look. Do you see how for decay, if you start reading the graph from left to right, it's going down, right? But for growth, it's increasing. So that's how we can tell from the equation whether or not something is growth or, from the graph, whether or not something is growth or decay. Well, how about from the equation? Can we tell from the equation if something is growth or decay? Well, here we go. If something is exponential growth, okay, then its function has a specific look. So the functions, the general form of the function looks like this. You've got this number a times b to the x. So to figure out if something is growth or decay, you look at this number b. If that number b is greater than 1, then we say it's growth. So take a look at this one. You have 3 to the power of x, right? So you ask yourself, what does the x belong to, the 3? Is that greater than 1? Yes, so that's growth. Okay, well, what about decay, exponential decay? That number b has to be between 0 and 1. So take a look here. Look at that x. Who does the x belong to? It belongs to the half. Half is a number between 0 and 1, so that's decay. Okay? All right, so let's take a look and see if some of these are growth or decay, right? So the first one, A, you have f of x equals 2 to the x. So what do you guys think? Somebody shout out at me. Is that growth or decay?
Growth.
Growth. What about B, 0.5 to the x?
Decay.
Decay. What about C?
Decay.
Decay again, because this number is less than 1, greater than 0, right? Between 0 and 1, decay. What about the next one, growth or decay?
Growth.
Okay.
So who does that x belong to? The x belongs to the 1/4, right? 1/4 is between 0 and 1, so it's decay. Even though there is a 2 here, you ignore that 2, right? Okay, questions? Right, so we're gonna graph our very first function today, okay? All right, graph and analyze each function, describe the asymptote, domain, range, y-intercept, and so on. Okay, first thing you wanna do when you have to graph something is figure out, is it growth or is it decay? So this first one, 2 to the x, we said above that it's growth, right? All right, asymptote. this is the default case, and for the time being, we're just going to look at the default case, and we're just kind of going to go with it until something changes. That's when I'll tell you how the asymptote will be different. But for now, our asymptotes are going to be y equals 0. Okay, remember what an asymptote is. It's a line. It's a line that the graph comes very close to but never touches. Since it's a line, it's got to have an equation. So the asymptote, again, it's y equals 0, not just 0. Just like we did for tangents, right? It was x equals blah, blah, blah. Okay. Before we do the y-intercept, well, actually, let's do the y-intercept now. The y-intercept is where it crosses the y-axis, right? So for the y-intercept, what you have to do is plug in x equals 0. So we're going to say y equals 2 to the 0. Okay, so just put in 0 for x. And what's anything to the power of 0? 1, right? So the y-intercept is x is 0, y is 1. X is 0, y is 1. That's where the y-intercept is, right? Okay. To graph, you're going to do a table, right? And to do a table, you can obviously pick any points that you want, but for exponential functions, numbers get big very fast, so I have a little system. Once you figure out that it's growth, for growth, I always pick these numbers for x. You're not bound to these legally. They're a choice. These just happen to be the most practical numbers to choose. So -1, 0, 1, 2, 4 of those, right? And now we're going to plug them in. So here we're going to do 2 to the power of -1, right? And remember, negative exponents, it makes the whole thing a fraction. So it becomes 1 over 2 to the 1, 1/2. Yeah? All right. 2 to the 0, we just said that's 1. 2 to the 1 is 2. 2 to the 2 is 4. Right. So I'm ready to graph. First thing is the asymptote. Remember how you could not draw a tangent graph without an asymptote? You cannot draw an exponential function without an asymptote. That is the characteristic function of an exponential function, right? Okay, after that, plug in your points. When x was -1, y is 1/2. The 0, that's your y-intercept. We had already put it there, and it matches with our table. X equals 1, y is 2. X equals 2, y is 4. Right? And look at how quickly that goes up. Next, what you want to do is graph this. Now, this, okay, I see this a lot, right? This was fine in kindergarten when we did connecting the dots. Not anymore. This is not an exponential function. You have to show two things. First, you have to show that it follows the horizontal asymptote here. That's the most important part. Second, an exponential function grows exponentially very, very quickly. So you have to show how quickly it grows. Right? Now that is an exponential function. Okay? All right. The domain, this is one where you get free points. There is no thinking involved here. The domain for all exponential functions is all real numbers. Okay. The range, it's going to be y is greater than or less than the asymptote. The asymptote was y equals 0, right? So now look at your graph. Does it sit above or below the asymptote? Above the asymptote means greater than 0. All right? You see how the asymptote and this are very similar, right? The value must be the same. Okay? All right. let's do a decay. So here is a decay. There should be a parenthesis here, right? Okay, so here is a decay. That's the first thing you should figure out. And, let's just write down here that is decay. All right, asymptote, always the same thing. Y equals 0, right? That's another free point. Y-intercept, y equals 1 over 3 to the 0. What's anything to the 0? 1. So it's 0, 1. That's how we're going to write it. All right. For decay, these are the numbers I choose. Right? I start from -2, so I just shift 1. I start with -2 and go to 1. Okay, so first I have 1 over 3 to the -2. Okay, a negative exponent makes the number into a reciprocal. So what we do here is you flip that fraction, so it becomes 3 to the 2, which is 9. Okay. 1 over 3 to the -1, flip the fraction to the +1, 3. If you don't remember these from last year, these exponents, let me know and, we can go through them, right? Okay, 1 over 3 to the 0, 1. 1 over 3 to the 1, 1/3. Right? Okay, let's graph. Asymptote first. Right. Now, when x is -2, y is 9, all the way up here. When x is -1, y is 3. At 0, it's 1. And at 1, it's 1/3. We're going to estimate the third. Okay? We're not sending anyone to the moon with these, so they don't have to be NASA precise, but it has to be in that vicinity. All right, and now decay looks like this, and you have to follow the asymptote. Okay? All right, questions? Okay, domain is all real numbers. There's a shorthand symbol for all real numbers. You can write out all real numbers, but there's a shorthand symbol. Look at how it looks. There are 2 ways you can do it. One is it's a double barred R, not just capital R, but it's like a double bar. Okay? Or another notation is an upside down A and a regular R. Those both mean all real numbers. Or you could just write all real numbers. Okay? Just don't leave it blank because that's your free points. Range. It's on top of the x-axis. It's on top of the asymptote. So y is greater than 0. Okay? Okay, Ashton, we can chat later, okay? All right. Questions on this? Okay, let's do one more. So here we have -0.5 to the x. Is this growth or decay? Decay. Okay, it's decay regardless of that negative, but now we have an added negative out front, right? So let's see what that is going to do to the graph. So this is decay, but you know what? Negative or not, my asymptote is still y equals 0. Cool? Okay, y-intercept, negative 0.5 to the 0. Y equals, sorry. Okay, this is y equals negative. Anything to the 0 is 1. So this time it's 0, comma, -1. All right, next. Here we go. Negative 0.5 to the 2. Negative 0.5, I'm sorry, to the -2 and to the -1. Now look at what I do with these. I don't like dealing with decimals. So here's what I do. Negative, what's another word for 0.5? 1/2 to the -2, right? Well, that is -2 to the 2. Now, who does that exponent belong to? The 2, the negative, or both? What do you guys think?
Both.
It belongs to just the 2, because had it been inside the parenthesis, then it would have belonged to the negative. But, so now this is just -4. So this one is -1/2 to the 1, -1/2. -0.5 to the 0 is -1. Yes, -1. -0.5 to the 1 is -0.5. Okay? All right, let's graph. Asymptote first. Okay. At x equals -2, we're at -4. -2, -4, sorry. At x equals -1, we're at -1/2. 0, we're at -1. Oh, I'm sorry. I made an error here. Sorry, I was trying to answer the chat and where's my mistake here? Here. I'm sorry. I was trying to answer the chat and do this at the same time. So where's my mistake here? What did I do wrong? This is -1/2 to the -1, right? So it would be -2 to the 1. Sorry, guys. It's -2. At x equals 0, we're at -1, and then -0.5. Okay. So look at what happens now. Here's where it follows the asymptote, and it goes down like this. So you see what happened? Because of that negative out front, the graph got flipped down. It's a horizontal reflection. It got flipped down, and that's what it looks like now. Okay, so now here's my question. What's the domain? Well, all real numbers again, because it's an exponential function. What's the range? This time, because it's below the x-axis, its y is less than 0, right? Less than, because it's below the horizontal asymptote. Okay? Any questions? Okay, let me tell you about your homework. Your homework is a handout, which is on MyJug already. And okay, so here we go. That's how it looks, right? You've got this, right? 3 or a couple graphs here. So first you have to figure out whether something is growth or decay. Here though, I've got basically the same setup. You should choose the x values based on whether it's growth or decay. And here, I haven't put in the values for the x-axis because I want you to do it yourself. And the reason for that is this. Sometimes the numbers get really, really big, right? So for example, here, 3 to the 2 is 9, 3 to the 3 is 27. So they get really, really big. And I want you to have the freedom of calibrating, or I want you to have the choice of either going up by ones or maybe by twos or maybe by threes, okay? Depending on this, right? You've got, all sorts of values here. So you are going to choose. However, in order to get full credit, you have to put values on your axis. Now, do you have to go like ad nauseum every single one? No. If you just put 1 or 2, it's okay. So if you just do 1, 2, I know you're going up by ones. And then here, let's say you want to go up by threes. 3, 6, and that's enough to tell me, right? Now, for this function, do you have to go up by threes? Not necessarily. I'm just using that as an example to show you how to label, right? And also, you can go up by ones on one axis and, by twos or fives or sevens on another axis. So that's cool as well, okay? You just have to label. So this is an exercise in, in labeling, in becoming that type of math student, in addition to graphing exponential functions. Okay? Any questions? All right, if you don't have any questions, you can go. I will see you guys Wednesday. This homework will be due on Wednesday, 7 p.m. like always. Okay, so I will see you next time.
Thank
Bye,
you.
everyone.